Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we are going to look at expression parsing and use this as an alternate example of a recursive algorithm. And in particular, the style of recursive algorithm that we're going to talk about here is what's called a divide and conquer algorithm. And there are quite a few different algorithms that use divide and conquer. The one that I want to do is, as I mentioned, expression parsing. So I'm going to put this in our utility package, and we'll go ahead and create a Scala object here for an expression parser. And the idea here is that I want something that if the user gives us a string, something like 3 plus 2 times 5, our function will evaluate this and give back the value of 13. Okay, so it's supposed to be able to do basic math operations, plus, minus, multiply, divide. We'll stop it there for now. And then also be able to do proper order of operations. So in this expression, it should find that the multiplication happens before the addition, so we get 10 plus 3 is 13, as opposed to 5 times 5 for 25. So how are we going to do this? Well, there are multiple ways that you can view this particular problem. And the way that I want to view it is using, as I mentioned earlier, divide and conquer. So when I look at this expression here, what I see is I see two things that are going to be added. And because this happens first, we're actually going to pull our expression apart in the opposite order. I want to start by finding the lowest precedence operator and splitting up my string on that operation. So for example, if this had been 4 times 3 plus 2 times 5, this would be 12 plus 10 for 22. But this plus here would be breaking the string up across two things that basically have higher precedence than it does. And so I want to write my method. Let's call it, I'll just call this method eval, short for evaluate. And I'll pass in an expression, which is a string. And since we're dealing with numbers, we're going to give back a double. And so I want to break this method kind of into two main pieces. The first piece is find the lowest precedence operator. Then the second piece is to deal with it. Do whatever we need to do based upon what we found. So for this first part, I'm going to write a loop, and I'm actually going to have my loop go backwards through the string. Equals expr dot length minus 1. So I'm creating a var named I, and I'm starting it at the end of the string, length minus 1. So in this case, that would be the index of 5. And I'm going to keep going while I is greater than 0. Turns out that since 0 is the first thing, you can't have a binary operator in the first location. So I'm good at stopping while I is greater than 0. I want to make sure that I increment I as I go through here. Sorry, not increment, decrement. We're counting backwards for this. To make this so I don't get zeros or get errors, I'm going to go ahead and put a 0.0 down there. We'll have to deal with that later. And what do I do inside of here? Well, one of the other things I didn't mention before is that I also want this to deal with parentheses. So in this case now the plus is not the lowest precedence operator. Turns out this multiply is, this multiply is, because operators are of the same level of precedence are supposed to be done from right to left. At least for addition, multiplication, subtraction, and division they are. So this is the lowest precedence operator if I have these parentheses. The way I want to implement that is basically if you're inside of parentheses, you can't be the lowest precedence operator. So I'm going to create a variable called op count, parens count, and right off the bat, if the ith element of expression is a close parentheses, then I'm going to take op count and add 1 to it. Students will, oops, sorry, not parens count. Students will also often ask why I add 1 for this and then subtract 1, which is what I'm going to do else. I'm going to subtract 1 if we find a close parentheses. Students will often ask why I add 1 for a closed parentheses and subtract 1 for an open parentheses, and the reality is it doesn't matter. Okay? Because the way we're going to write this code, 0 is the special number, and that means we're outside of parentheses, and whether we go positive or negative isn't significant as long as one of these is addition, one of them is subtraction. In this case, because I am walking backwards through the string, it turns out that the closed parentheses is the first thing I will find. So I'm good with incrementing here, but really it doesn't matter which one I find. So what if I don't have a parentheses? Then what are my other possibilities? Well, it could be digits for a number, or it could be an operator that I'm interested in. So I'm going to start with my lower precedence operators. Those are the plus sign and the minus sign. Okay, so if the character that we're looking at is either a plus or minus, what do we need to do? Well, we found an operator. So I actually want to introduce another var here. I'll call it oploc for the operator location. And I'm going to start it off equal to -1, which basically means we never found an operator. However, if I did find an operator, the plus or the minus, in this case I want to remember it. So oploc equals I. That's the location of our operator. Oh, I forgot something here. Not only do I have to have found the plus or minus, it has to be in a position where parens count is equal to 0. So if the parens count is 0 and the expression is either a plus or minus, I remember where I am, and I'm going to do one other thing here, and that is I'm going to set I equal to -1. Why am I doing this? Because it turns out that the way we're writing this code, the first plus or minus that I see that is not in parentheses, I automatically know is the lowest precedence operator. I don't need to keep going. So I want something that's going to cause this while loop to break out right there immediately. Else, if, well, we have something that's similar here. Parens count is 0, and let's just copy this. Except it's not for plus and minus. Now it is for multiply and divide. Okay. We'll start with this, see if we need to add something to it. If we're not in parentheses and we see a multiply or divide, well, we have now found an operator. So we're going to remember it. But I can't set this to -1. And the reason is, as we saw from this string, when I see this multiply, I can't stop. That is not the lowest precedence operator. I have to keep going. Maybe there is a plus or a minus. Now, and so if I hit the plus or minus, I have to jump out. What if there is no plus or minus, though? When I hit this divide, I don't want to forget the multiply because I had the divide. So I need one more condition in here. Let's go with less than 0. So this is if the parentheses count is 0 and I haven't seen an operator yet and I'm currently on a multiply or divide, then I remember the location for that. Otherwise I then subtract 1, repeat, repeat, repeat until we get to the very beginning. And this is our only breakout here. note that when I set this equal to -1 and then I subtract, I'm guaranteeing that I will break out of here. So at this point, we should have set oploc to the appropriate value. We'll come back in the next video and we'll see how we can deal with that value, whatever it is.